Fuel flows by gravity from each tank to the reservoir, which is the lowest point of the fuel system. There's 4 check valves that prevent backflow. And then the ejector boost pump and the aux electric boost pump are submerged in the reservoir. Fuel is pumped by the ejector boost pump or the aux electric fuel boost pump. With the fuel boost on normal, you should get a aux fuel pump on and fuel pressure low light on. It should blink on and off like this. As the pressure rises, it should turn off. As the pressure decreases, it should turn back on. This is a go, no go item. If it's not working, the pilot should abort the flight until repairs can be made. Sometimes that's what happens when you clean the fuel filters on the engine-driven fuel pump or firewall fuel filter. It messes the pressure up somehow, and it'll take 2-3 starts for it to start acting normal again. We should get electric continuous flow, and the aux fuel pump on light should stay illuminated. Welcome to the part that's the poorest design on the Caravan. The left and the right wing fuel tanks meet together in the fuel reservoir hopper tank. Instead of installing a check valve, they installed these flexible flapper valves that fight against gravity, trying to keep fuel from transferring from one side to the other. Thus, the only way to really control the fuel transfer from one side to the other is to physically shut off one or both fuel main valves. Okay, an overview of the system in the fuel reservoir tank. In red, we have the ejector pump, and in green, we have the low fuel level switch, and in blue, we have the aux fuel pump. A red fuel reservoir low level light will illuminate when the fuel level in the reservoir is less than 2.15 to 1.95 gallons. The electric auxiliary fuel pump is controlled by a switch labeled fuel boost and has off, normal, and on positions. When in the off position, the boost pump is in off. When the switch is in the normal position, the boost pump is armed and will operate when fuel pressure in the fuel manifold assembly drops below 4.75 psi. If the fuel pressure drops below 4.75, the pressure switch will remain closed until the fuel pressure rises to 6.0 psi. When the boost pump switch is on the on position, the boost pump will operate continuously. This position is used for engine start. The electric fuel pump produces more than ample amount of supply to run the engines at full power. Anything not needed is returned back to the reservoir via the ejector fuel pump. Here's a good view of the pressure switch that's mounted onto the manifold. Okay, should the annunciator pressure lights not blink on and off like they're supposed to? The two probable causes could be the pressure switch, but usually it's the relay that's mounted in the area of the reservoir. This relay sometimes sticks or goes bad, not preventing the low pressure switch from operating correctly. The problem with this relay is when you order one, it only comes as a relay, and so you have to build up a harness to the connector. I would recommend that you, when you receive one from Cessna, that you build one up and have it waiting in stock, because it takes some time to build up to be able to install it. Okay, here we have the fuel sump drain that is located on the lowest portion of the fuel tanks, on the fuel blister of the wing tank. They put these flush fuel drains to cut down on the drag, make the wing a little bit more efficient, but it has its drawbacks and it has its advantages. Eventually, one time or another, you're going to get a new pilot that's going to decide he needs to sump each one of his fuel drains when it's below freezing. This is required to do, brings about some challenging events, because what happens with water when it settles in fuel, it naturally goes down to the bottom of the tank, the lowest portion of the tank. What's in that lowest portion of the tank? One of these fuel sump drains. The way these fuel sump drains operate, you put a Phillips screwdriver onto this. If you push it straight up and down, like the pilots are supposed to do, of course, they'll get fuel out of it. But sometimes that's what happens, is on the back side and on the inside, where this hole is, some ice will get inside that hole and on the top of that plunger and keep it from springing back into the closed position. And so you're going to have a gusher on your hands. Any more than 3-4 gallons of a big fire should there be a spark somewhere. Another thing that the pilots do, sometimes when they push straight up, they twist it accidentally one way or the other, and if they twist it counterclockwise, it's going to stay in the open position. And so they're going to call you over, and it's up to you to stick a screwdriver in, preferably as long of a handle screwdriver as you can get, so you can do it at an angle without getting fuel on yourself and taking a fuel bath. And you're going to have to wiggle it around and hope that this plunger, as you rotate it, snaps back into the closed position. Now that's one of the many maintenance advantages to having this kind of a sump drain is sometimes drain will leak, the fuel will leak around the O-ring of this plunger. The way to change the O-ring without defueling the tanks, you put your Phillips screwdriver in the slot and rotate a quarter of a turn clockwise. This will pop out your plunger with your O-ring exposed right there. And up inside the valve, there's another valve that closes when you pull this one out so that all the fuel doesn't come out. You carefully change it. Put a little bit of lube on it and carefully push in on it and rotate it counterclockwise a quarter turn to lock it back in place. And to function test it, you just push in and out on it, and this should fall into the seated position and no fuel should leak. The O-ring for this is difficult to find in the IPC, so I provided you with the reference of the IPC and the part number. It's also a very odd part number, so you may want to write this down. Welcome to the overview of calibrating the fuel indicators. Anytime during one of the inspections where it calls out to calibrate or check the calibration of the fuel indicators, this is an overview of how to do it. And also anytime you have to change your fuel indicators, you need to repeat this procedure. First thing you're going to want to do is defuel the airplane. Then you're going to locate your leveling points. So you jack the airplane to level it for pitch, And for roll you level across the seat tracks. And then you're going to add however many gallons back into the fuel tanks to fill up the reservoir again. Then you're going to want to jack the nose up 1 degree, which is actually the true flight configuration of the airplane. Then you're going to have a resistance load dummy that you put on the inboard fuel transducer. You're going to put it in series, so you're going to have one end hooked to your other wire and another wire after you remove the terminal. You're going to hook it to this middle terminal, and then you're going to adjust with adjustable rheostat the correct amount of resistance. Then the next step is to go to your fuel indicator. The next step is to get back in the cockpit, and you're going to want to make sure that the needles are covering the red line at 0, and if they're not, then on the side or sometimes on the back of the gauge you have a gain and you have a null. You adjust, one of them is for the low level and one of them is for the high level. So you adjust the one that corresponds with low level to zero it out on 0. And then you're going to dial in your dummy load from your resistor. And you're going to adjust it to the highest mark here. Adjust it to the 11 mark on the gauge. The same thing on the other side. So that's just a quick overview. Please follow the maintenance manuals, the current maintenance manual. Have a good day.